Recording is started or not, we don't know. Okay. Started. Very good. Guys, these are the disk volumes. Okay, disk volumes. Simple, spanned, stripped, mirrored, RAID 5. Okay, these are the volumes. Okay. So here for an explanation. In generally, when it comes to the RAID, so we have to go through the RAID part only. But here I'm trying to explain very simplest thing. Okay, simple volume means it's a simply a disk. Earlier days we have a partition. Name is partitioning. Now it is having a name is simple partition. What is meaning of simple volume? So instead of saying a partition, we are calling it as a simple volume. So disk volumes. So these are the volume types. Okay, as per a Windows. Okay. Simple volume. Simple volume is simply say like earlier we use a simple volume, like simple volume means partition, disk partition, single disk in a single disk only. So this is a disk, guys. So this is my disk one, this is my disk one, and I create a partition like this. I create a partition. It's a single disk. Okay, in this disk I'm creating a partition. So that is called a simple volume. So that is called a simple volume. It is called a simple volume. That's it. Next. So another one is showing here, it is spanned volume. Spanned means, for example, I have a two disks are there. For example, I have a disk. The disk size is like a 1 terabyte of disk is there. Okay, it is a 1 terabyte of disk partition or a disk partition or a complete disk, anything, no problem. Okay, this is a disk or a disk partition is there, 1 terabyte of disk. Now it is not enough. I put a lot of data in it. So it is not enough. So what I have done, it is not enough. So what I have done, I added another disk. Another disk. For example, added a 2 terabyte of partition is available. 2 terabyte of disk or a 2 terabyte of partition is available in another disk, separate disk. So I combine these two disks together. And make it as a single large volume. Either 1 terabyte, 1 terabyte, or 1 terabyte, 2 terabyte, or maybe 500, 1 terabyte, or maybe 100 GB, 2 terabyte. Okay, anything, any combination we can make it and make it as a single large volume. For example, this is my E drive. Okay, so this is my E drive. So my E drive size is now, earlier it is 1 terabyte. Now it is 3 terabyte. Earlier it is 1 terabyte. Now it is 3 terabyte. Okay, so that is spanned volume. That is called as spanned volume. Okay, that is spanned volume. So this is a simple volume. So here it is. We generally create a partitioning. It is no problem. Okay, so that is called a simple volume. We create a disk partition, that is called a simple volume. You combine a two physical disk or a two partitions in the separate disk, that is called a spanned volume. So this is the combination of spanned volume. Combination of two or more disks, two or more disks are two or more disks make single volume. It is called as spanned volume. That is called as spanned volume. So spanned volume. So never seen what size of the disk is also there. Okay. So better I will write separately. Simple volume. Simple volume means it's like a creating disk partitions. It is nothing but a single disk. When you sing, it's a single disk creating small partition. In single disk, we are creating partition. It is a single disk, not multiple disk. It is a single disk. Okay, and in single disk, create partitions. Otherwise, you can write divide a single disk into single disk into multiple partitions. Partitions or drives. Okay, so that is called a simple volume only. Spanned volume. Spanned volume, combination of two or more disks make us a single volume or a single drive. Drive means C drive, D drive, E drive. That is also we are calling it as a drive, right? So that is a single drive. Combination of single drive. Okay. We can combine can combine can combine different size of disk or partitions. Different sizes means example, so 1 terabyte of disk plus 2 terabyte of disk we can combine, so then it will become 3 terabyte. So it is not required always like both partitions should be same, because in the stripped value it is there. It is not. It is not a RAID level. Remember, that is not a RAID level. 1 second. Yeah, hello. Very good. Sorry. Yeah, here it is. It is a not a RAID level. Now it is comes to RAID level. RAID levels are these three are a main RAID levels. So stripped volume, spanned mirror volume, and many. Okay. So I'm also directly telling these things. Okay, and also in a RAID also I will tell once again what are the comes in RAID level. So what is this stripped volume? Stripped volume is as per the RAID level. It's a RAID 0. RAID level 0. The remaining is RAID level 0. We combine combination of two or more disks and make a single volume. Okay, or a drive. So it's like a depends upon guys. We show in a Microsoft, but RAID is a open protocol. RAID is a basically open protocol. Linux, Unix, and like the different things are there. Okay, so we can combine. We can combine only same size disk or a partition. Same size. Single volume is actually a basic disk. Simple volumes are actually basic disk. Spanned volumes, you need a dynamic disk. Okay, so these are all also designed same dynamic disk only. Okay, so example of same combination of this is, for example, I took a 1 terabyte and it is 1 terabyte, it is 2 terabyte of disk. Okay, okay, so like that. Okay, next. So RAID level already I told RAID level 0. Combination of two or more disks make a single large volume. So we can combine only same size disk or a partitions of the disk. Of course, we use a dynamic disk for this one. So all volumes we use dynamic disk. So no need to tell again and again, but so better add a one. It's look like one more point. Okay. So it's not a basic disk we use dynamic disk. Okay. Dynamic means we have to convert basic to dynamic. Then only we can able to combine. No redundancy. No redundancy. No redundancy means okay, no disk failure. No disk failure. Meaning is if any disk failed, we cannot access data. Cannot access data. Okay. If any disk is failure, can't access the data. So same thing, same goes for here also. We can't able to access the data. But this one comes under a RAID level. Okay. This is only to create large volume sizes. A large volume sizes you want to create, use a stripped volume. So in diagrammatically, will show like this. So practically also we can see. So this is a single disk. You can take two or more. So no problem. You can take 3, 4, 5, 6 kind of stuff. Okay. So this is for example disk 1. This is the disk 2. Okay. For example, this is a E drive. My initial E drive size is 1 terabyte. Next, it is not enough, so then I will combine more disks. So the second disk also must be 1 terabyte only. Okay, so compulsory take 1 terabyte, 1 terabyte, 1 terabyte only. So this is a overall like a, so 2 terabyte we'll getting. Okay. So this type we call it as a stripped volume. Okay. What is the stripped volume? It is nothing but write 0. This is a stripped volume. This write 0. Okay. So we can combine like a combination of 2 or more disks. No parity. Okay. No disk parity and no disk failure. Okay, no disk failure. If any disk failure, total data loss. Total data loss. So that is a stripped volume. Okay, I have a little bit space here. I can use it because we'll need one more mirror volume and write 5, write 6. Enough, no problem. So I use this space. Okay. Yeah, we can use it space. I am taking 2 disks here, guys. So up to now, okay or not, guys? Stripped volume because it's a write 0. Write levels are start with here. So next one is mirrored volume. Guys, understand stripped volume?
Yes.
Yes, sir.
Yes, sir.
So mirror volume means it is a write level 1. Okay, it is a combination of two disks. Combination of 2 disks only. It's not a more disk. Okay, combination of 2 disk array drives. We can say, but best is take a 2 disk. Best is take a 2 disk you are configuring. For example, you have a disk, you have a data in the disk. There is a possibility of fail of the disk. There is a possibility of fail of the disk, right? Failure of the disk possibility is there. Then what I do, if disk is failure, but still I can able to access the data. It is a single disk failure. It is a single disk failure without parity. Without parity. Parity bits are not there. So that's parity thing I will explain in a write 5. But here it is without a parity. It means if any one of disk failed, okay, we can access the data. Even though at one disk is failure, still we can able to access data. No need to wait for the backup and restore kind of stuff. So simply we can able to access data. So that is called a mirrored volume. Okay. So here it is. We take a 2 disk combinations. Okay. We take a 2 disk combinations compulsory. We should take like this example. 1 terabyte of disk plus 1 terabyte of disk if I take in, the resultant is 1 terabyte only. We don't get a 2 terabytes here because copy what are the data in the first disk, same data will be copied into second disk. Okay, so what are the data in the first disk, same copy maintained in the second disk without we are copying, so it automatically copies. I put a data, same data will copy into disk. Okay, so that's why it is both are are a same data maintaining. So the total size it is showing 1 terabyte only, but you are using 2 terabytes. 2 plus 2, 2. 4 plus 4, 4. Like that in a mirror volume. Okay. Of course, we use a dynamic disk. So any volumes we use a dynamic disk. No parity, same volumes. Okay. Again, dynamic disk. Next important is same size disk or partitions. It means from disk 1 terabyte, some from disk 2 1 terabyte. Okay, same sizes only. All are same sizes only, guys. So because of in a spanned volume, we can take a different sizes, but in a all RAID levels, we take always same sizes only. So important in a RAID mirror volume, it is a RAID level 1 combination of 2 disks only. So we can take only 2 disks. We can't take 3 disks here. Okay, combination of 2 disks only. Okay, we take only 2 disks. We can't take more than 2 disks. Okay, so 2 disks. Okay, next single disk failure. One disk is failure, still we can able to access the data. Next, tripped volume, RAID level 0, combination of 2 or more disks, single large volume we can able to get it, single large volume we can able to create it. Okay, no disk failure. If disk is failure, we can't access the data. Okay, of course, mirror having some problems, so then we'll see the mirror kind of problems also. We'll see. Again, I'm explaining here. This is the 1 terabyte of disk. This is 1 terabyte of disk. I combined these 2 disks with a mirroring. Okay, so that is called a mirroring, right? Mirror volume. Okay, so this is called a RAID 1. Okay, it is a single disk failure without parity. Without a parity, even though one single disk is failed, no problem. Still, we can able to access the data. Okay, so it consumes 50% of total volume size. Okay, remember that one. So it gives like this. It is 1/2 of total volume, total disk volume size. It means if I take 2 terabyte, 2 terabyte, I got a 2 terabyte only. 4 terabyte, 4 terabyte, 4 terabyte only, because 4 plus 4 is 8, but I'm getting 4 only. Means half of the total volume I'm getting only. I'm getting. Okay. So that is another one. So of course, mirror breaks. And disk failure. When a disk failed or replaced, and replaced. Okay, so this is another point is there. So mirror, what happened to the mirror is will be broke. It will be broke. Mirror breaks when disk is failed and replaced. It means you have a disk. Disk is you put it offline, no problem. But if you remove the disk and reinsert the disk back, okay, the mirror will be broke. Okay, so that is your mirror volume. So we'll come to the RAID 5. Okay, so RAID 5 is also a single disk failure.
Sir, what is parity, sir?
Yeah, I will explain. I will explain. Don't worry. parity. Next one is write 5 volume don't have any name. The write level is write 5 only. The name, the level of is a write level is 5. So when it is come to the level 1, 0 is there, 1 is there, next one is 2, 3, 4, then 5, 6, 7, 8, 9, 10. It has to go. But where is the 2, 3, 4 and why you jump to the 5? Because of 2, 3, 4 is there. But problem with that one, so it is not implemented or not suitable for enterprise purposes. So there is a different type of implementations are there, but not suitable for enterprise purpose. Automatically, there are disqualified in the uses of write levels. So 5 is more beneficial. 5 is enterprise level. Okay, mirror volume is simply say I'm putting here for a separation purpose. Mirror volume for a small office, okay, or a home, okay, home office or home purpose. Small office, home offices, not for enterprise, not for enterprises also, okay. But this is for an enterprise purpose, enterprise solution made by this one. Here it is, we use this a combination of minimum 3 disks, 3 or more disks as per the text, 3 or more disks, but generally we use 3 disks only, okay. So generally we use 3 only. So what I'm doing is I put a bracket. So more is also possible, 3 or more disk, combination of 3 or more disk are a partitions, 3 different disk partitions. A combination of 3 or more disk. It is also a single disk failure. As for the 3 disk, it is a, as for 3 disk, it is a single disk failure, again with parity. So that is a important thing. What is a parity? It is always big question. So we'll see. If any one of disk failed, any one of disk failed, okay, still we can able to access data. Next, when a disk is failure and you replace disk with new disk, data resync SYN resynchronization. So I put a resync for understanding. Data resync or regenerate when you replace the disk, failed disk. Okay. Failed disk, or you repair the disk. So when you replace the disk, data resync or regenerate into the new disk, okay, by use of parity. That is the main purpose of write 5. So I will explain parity by diagrammatically. So first of all, I want to type all the text language. Of course, we use a dynamic one. Dynamic disk we use it. Enterprise purpose. This dynamic this is for
Sir,
enterprise. Yeah.
sir, in RAID 5 volume, can be combined different size of disk or same size of disk?
Same size, same size disk. Very good. Okay, only in a spanned volume because it's not in a RAID level. So we can use different sizes, but stripped volume, mirror volume, RAID 5. So we use same size disk only, dynamic disk only, and it is RAID 5 is a enterprise level. In RAID 5 we have a parity. I will explain the parity kind of stuff. Okay. But this is the important point related to the parity. So advantage of using parity is we can regenerate or resync the data into the new disk. Okay, it is a single disk failure. Next, the combination of 3 or more disks, right? So 3 or more disks. So for example, you take a 3 disk. So 1 terabyte plus 1 terabyte plus 1 terabyte. Meaning is you get a 2 terabyte of size. It means you take a 3 disk. In case you take a 3 disk out of 3 disk, okay, out of 3 days we get 2 disk volume size only. Okay. So like a mirror broking, it won't happen here. Like a mirror is broke when disk is failure, right? In a RAID 5 it is won't happen. It is resynchronized. So no mirror broking here. So that is a RAID 5. So in a picture wise I will explain. I will try to explain like this. Space is not enough. First we'll take this size. Yeah. Okay, 3 disk. 1 terabyte. 1 terabyte. So usually for me, I took always for understanding 1 terabyte. You take 2 terabyte, 2 terabyte, 2 terabyte. Total volume is 4 terabyte. You take a 4 terabyte, 4 terabyte, 4 terabyte. You will get a 8 terabyte volume. Okay, like a 2/3 volume, you will get it. So this is the 2 terabyte totally we are getting. Next one is it is a RAID 5 volume. It's a finally RAID 5 volume. Okay, it is a single disk failure with parity. Okay, maybe in our engineering, okay, maybe may not be. So a lot of people may not in the electronics or computer science. So whatsoever it is, guys, parity bits are there. Parity bit means it's a bit from your data only. You have a data, but data is in a binary format, right? So data finally is in binary format. Parity bits are some from your binary format only. It's a combination of some bits like this, like 111 is there. So they put a fours ones are there like this. Okay, so they will combine certain bits together and make it as a small amount of size of thing. Okay, parity bits are representation of data. Parity bits are representation of your data in the smaller size format, small size data formats only. Okay, so how these parity bits are working also we'll explain. So for example, guys, This is my disk 1. The disk 1, I put a data, like for example, my data name is A. I put A in the disk 1. The A's parity bit stores in other disk. A's parity bit stores in other disk. Okay, just for our understanding only, it is not really like there is a lot of parity, parts of data, full data, parts of data, full data, parity data is separate, it is there. I'm not going to that much depth explanations. I'm going to understand. Guys, you put a data in the one disk. The disk, you put a data in the a disk. You don't know where you put it, but automatically data stores in a disk. But parallelly, the parity bits of data stores in other disk. For example, you put a data is in D2. The parity bit stores in other two disks. So what is the advantage of this one? You have a data C in the disk 3 and the parity bit stores another disk. What is the advantage of this parity bit is, if in case a disk is damaged, you replace a new disk. In this place, okay, and you resynchronize. What happened? Data will be regenerated. Into these disks. Data will be regenerated into these disks. Again, data will be forms. So this is RAID 5. This is RAID 5. Okay. I will tell again. So take some seconds. Okay. Just a second only, minute only, and then I will explain. Okay. And meanwhile, try to get into the understanding. Okay. Two by third of total disk size. Okay, 2 by third we are getting 1 terabyte, 1 terabyte, 1 terabyte. We got a 2 terabyte. Okay. Single disk failure with parity. Now tell me, guys, do you got the point? Parity point. What is parity? It is a it is giving some other parity bits. Okay, so you can check this original data, how it is there, and how the parity bits are stored. Like now it will be passed through some gate. Okay, you will get it. The how really parity bits. Actually, the parity bits are like different sizes. Are there like the size of the parity is compared to original data is very less. Okay. So it's a parity means it's this form of data from your data only. Data is created and it stores in different place. Okay. What is parity? How it is created? That is not our part now. Okay. It's very simple, guys. In one disk, you have a data. The data's parity bit stores in another data, another disk. Sorry. Okay. So you have a multiple disks. In one disk, you have some data. The data's parity bit stores in different disks. That's it. What is the advantage of that one? What is the advantage of parity bits? If in case a disk is failure, you can, when you replace the disk with a new disk, automatically data will be regenerated. Data will be regenerated. So that is called a parity. That is a use of parity. That's why RAID 5 is enterprise level RAID. Okay, next. So these are the 5 levels of RAID. Okay, 5 levels of RAID. But one more RAID is there, that is called RAID 6. RAID 6 is not a separate RAID. RAID 6 is also RAID 5 only. RAID 6 is also RAID 5 only. But here you use combination is different. RAID 6 is RAID 5 only. But only thing is, in a RAID 5 we use 3 disks. Here we use 5 disks. Okay, RAID 5 we use 3 disks. Here we use 5 disks. Okay, it is a 2 disk failure. It is a 2 disk failure. So 2 disks can able to fail, allowed to fail. Okay, it is a 2 disk failure with parity again. RAID 5 is a single disk failure. 3 disk we use, single disk can able to fail. It is a 5 disk failure. Okay, 5 disk, combination of 5 disks. So 5 disks, combination of 5 disks, 2 disks can be failure, no problem. Last means in one batch, people are asking me a question, that is, sir, when to an organization, which type of RAID they will use it? What is your suggestions, like which type of RAID and how to decide how much cost we put it? Okay, so that is the question. So guys, think there is a risk management is there. So risk management, understand word risk, RISK, risk calculation of organization is there. Okay, in organization everything is risk management. Just for example, you have a bike in your home. Okay, bike is there, like you want to buy a bike, or maybe you already bike is there, you are regularly using. Okay, so what is the possibility of you are getting a problem? What is the possibility? You must maybe you met an accident, so you have to wear a helmet. Maybe your bike engine oil, you should maybe it will give you some problem. Engine, battery, like there is a possibility of in the future and in the same day, or maybe in the next day, or maybe in the week, you may get a problem on the bike. Okay, so what it is, we have to check it. Okay, point is where I am going through it, the things is sorry, yeah, it depends upon the risk. So we have to calculate the risk, and we have to use this kind of stuff. For example, I have a server or maybe a desktop, single hard disk is there. Okay, for me. Okay, I feel there is no risk. Hard disk won't down. For example, in our Pune office, what happened? We have a front office desk is there, front office system is there. So the disk got failed. One time it is failed, and we replace the disk and we reinstall the operating system and everything, and again we start working. After few days means after 2-3 months, again disk is got failure. Okay, so what is the solution, you will tell? just for it is a front office desk, but it is a front office desk. Disk got failure. The guy who is sitting like Vikram is unable to take a printout of receipts, unable to access the data that day. Okay, of course we have a backup luckily that time. Okay, so Charan sir took a backup and store in his laptop also. So luckily we have a last backup, we can able to restore it. That is a good thing. But if one of the disk failure is unable to access data immediately, okay, and of course the recent data is also difficult, right? So we got a disk failure. What is the solution? You will tell in that situation. Guys, understand scenario or not? I ask a question. Do you got the question at least? Understand your my question?
Yes, sir.
Then what solution you will tell?
So could you repeat the question?
Very good. Okay. Mirror volume, RAID 5, spanned volume, stripped volumes are there, right? So my question is, in our Pune office, we have a desktop is there. So front office desktop. So Vikram is working on it. All of the sudden, the disk failed. So this stopped working. So we replace the disk. We install again operating system in the new hard disk, and finally we install OS. Everything is done good. Again, after 2-3 months, again the new disk is also failed. Okay, so luckily we have a backup, so we restored it. So that's the part completed. Now the thing is, in a future also it may be failed, right? In a future also it may be failed. So what is the thing you want? You will suggest, like all of the sudden disk is failure. You can't able to access the data. First of all, backup is there. There are not. That's a secondary one. Okay, backup is important, but to restore the backup, it will take time. To restore the backup, it will take time. The student came up and he is asking, he want a payment receipt. You want a payment receipt, right? So that is very difficult, right? So immediately has to print the receipt, right? Or maybe Charan sir asking a question like, I want certain details. It's a disk failure, come back later, he can't say. So what is the solution you suggest to overcome that kind of situations? So that is a risk because of every 2-3 months or 4 months or maybe a 6 months, all of the sudden disk is failure. So you may not access your data. Okay, you may not access your data if disk is failure, right? Which volume you will suggest
Mirror
in that
volume.
situation? Mirror volume. Okay, good. Any other? Actually, mirror volume is correct one. Okay, because stripped volume, if you need a big size of the size, disk size, volume size, not a disk size, you need a big volume size, you will go to stripped volume. For a small office, small organizations, mirror is enough. Mirror is enough because of it's a regular desktop, not a server. It is a Windows 7, Windows 10. Okay, so it is a regular desktops. Only stripped, spanned, stripped and spanned simple, and mirror volume will be support. So RAID 5 may not be support in a depends upon the version of a, it depends upon version. Okay, so mirror volume is generally supported. Okay, so best one is, so for organization, small offices, for home offices, for home desktops and laptops, mirror is better solution because it's a cheaper. than a write 5. So if one disk is failure, still we can able to access the data. So write 5 is an enterprise level. So I need a 3 disk. It means one disk is already used for operating system loading, 3 disks for a storage. Additional cost on it. So more burden on your processor. So small offices, we don't prefer small offices, homes. We don't use write 5 kind of stuff. That too, we need a server operating system or dedicated write controllers. So that is a based on the risk factor, based on risk and organizational level and budget level, we suggest write 5 or a write 6. So failures are more frequent. So then we'll go with the better levels, right? Like this. So this is a write 6. Write 6. Okay. So combination of 5 disks is a disk 1, disk 2, disk 3, disk 4, disk 5. So totally 5 disks. So we'll get a 3 disk volume. Okay. Combination of 5 disks, we get a 3 disk volume size. We'll get a 3 disk volume size. Okay. So 2 disk failure with a parity. So this is a write 5 only. There is a no write 6, guys. Actually, write 5. It is a write 5 with a 5 disk. Exactly say it is write 5 with 5 disk. Simply say 5 disk and 2 disk failure with parity. Write 5. We use write 5. We use 3 disks, single disk failure. Write 6. We use 5 disk, 2 disk failure. That's the difference. Okay. So this is a totally write 5. Write 6. Okay. So you want a diagram, then you can also put it 5 disk here, 3, 4, 5. Guys, scenario questions sometimes very important. Understand in a scenario levels also. Why I'm telling, sometimes in an interview, not only a plain questions, also in interview scenario based questions, means they will ask in this particular situation what you will do. They'll give you a situation and what you will do. So that is very important to understand, guys. So you, not only you people, like every batch, it is same thing only, because we came from the college days and we studied questions and answers, prepared for interviews, self introductions, communication skills, right? But in general, we don't understand we don't estimate interviewer. We cannot estimate the interviewer, right? So we think it is the plain questions or depth questions, but sometimes it is very simple, a very basic a scenario based or a very simple observation related questions, scenario based or observation based questions. So obviously you will get a little headache that time, because problem is we know the answer, we are unable to tell because we don't understand exactly really that is a question or answer kind of stuff. I'm talking and I'm typing all these things, but now I'll just okay. So this is a write 5. Guys, not only this one, we have a write 10, write 50 kind of stuff is also there. Write 10 means it is a write 1 plus write 0. Okay. Write 50 means it is a write 5 plus write 0. So if you want to achieve mirroring and also hues volume. Okay, it's a combination of mirror and a stripped volumes. So like this, you can get it like, for example, ride 0. What is ride 0? Stripped volume. What is a ride 1? Mirror volume. So I'm combining like this. So just for example, I will divide like this. Just for understanding, this is a ride 0. This is a ride 0. No. Mirror. Think like this is a mirror. Okay. These two are a mirror. Mirror. If disk is failure, no problem. Okay. Like disk 1, disk 2, disk 3, disk 4. Okay. Disk 1, disk 2, disk 3, disk 4. 4 disk. Disk 1, disk 2, mirroring. Disk 3, disk 4, mirroring. And whole combination is whole combination is stripped. Whole combination is stripped. Or reverse side also we can configure. Okay, so no direct option called a ride 10 kind of stuff, but it is okay. Okay, so ride 10 direct option is not there. You have to configure as per your requirement which one is you want. You want a both redundancy as well as as well as huge large volume. So then ride 10. You want a ride 5 concept plus huge volumes. Volume size is required more, and as well as you want a redundancy with the ride 5. So then ride 50. Okay, like this. This is a your ride kind of stuff. Guys, understand the ride concept. I started with volume types. That's why I told simple volume, spanned volume first. But in a ride levels, when it is comes to the ride, so I use a word called ride so many times, but what is this ride? We never given a abbreviation for that one. Ride means redundant array of independent days or inexpansive days. Independent days are inexpansive days. Okay. Independent days are inexpansive days. Multiple physical days drives into one unit. Okay, that is ride. Guys, in a ride, two type of rides are there. One is hardware ride. Another one is software ride. Software ride means using Microsoft Windows servers or Linux, okay, operating systems, okay, different operating system or applications. So the ride related applications. So that is called a software ride. Using some applications, if you configure ride configuration, so that is software ride. Windows servers we can able to do it. Linux also we can able to do it. Unix also we can able to do it. So in a ride levels. Okay. So that is called software ride. So hardware ride is a dedicated ride controller is there. Dedicated ride controller or integrated integrated with SCSI or server motherboards. Sometimes it is integrated with your SCSI controllers or server motherboards also. So that is dedicated RAID controllers are there. Okay. So RAID levels are RAID 0. Important RAID levels are RAID 0, RAID 1, RAID 2, RAID 5, RAID 6, RAID 10, RAID 50. If in interview ask or anyone asks like is RAID 7 is there, RAID 8 is there? Yes, it is there. So don't worry, it is there. The problem is it's not implemented. Okay, it is not suitable for enterprise solutions. So that's why we are not talking about it. Guys, what is the RAID 5? RAID 0. So what is RAID 0? You people don't talk anywhere. It is a stripped volume. How many disks we use? 2 or more disks. No disk failure. No disk failure. So we cannot, if any disk failure, total data loss. We can't access data. If disk fail. Okay. It is opposite, like a reverse side I am telling. What is RAID 1? Name of the RAID 1?
Mirror volume.
Very good. Mirror volume. How many disks we use? 2 disks. Okay, 2 disks we use it. How many disks can be failure? Single disk failure with parity. Can access data even if a disk failure. RAID 5. RAID 5 volume only. How many disks we use? 3 disks or more. 3 disks or more. How many disks can we failure? Single disk failure. With parity. Can access data even if a disk failed. Okay, parity means it regenerated data into the new disk once you are replace the old disk or a failed disk. Okay, a disk is failed, you replace with a new disk, automatically data will be regenerated into that one. So that is the use of parity. So parity means it's data from your existing data. Okay, it is your binary bits, the parity bits generated from actual data. Parity bit stores in a different disk. A disk contains a data, the parity bit stores in other disk. So that is a parity. RAID 6 volume is the RAID 6 volume only. It is a RAID 5 only, but in a RAID 5, if you use 5 disks, it is automatically RAID 6.
2 disk failure.
Very good. 2 disk failure with parity. Even if 2 disks are failure, still we can able to access data. So it is a combination of RAID 0 and RAID 5. Sorry, RAID 0 and RAID 1. That is again you have to check it. Okay, RAID 5 and RAID 0. PPTs also I will show you that one, so don't worry. So like this you can able to do it. This is a disk are added, so don't worry. So get disk, clear disk, initialize the disk, get volume, format volumes are a basic commands. This is the write. So about a write redundant array of independent disks, combination of multiple disks into single logical unit to provide fault tolerance and performance. Disk mirroring parity information is there. Okay, so compulsory read this point also, guys. Write level strip set without parity or mirroring. No parity, no mirroring here. No disk failure. Write one. Mirror drives, no parities. It's a parity. You can see A1, A2, A3, A4, AP. Parity bit. Like this. So parity bit stores in a different levels. Parity bits. So it's a write 6. Okay. Write 5, write 6. Now this write 1, 0. So you can see it is a mirror between stripped volumes. Strip. So one set is a strip. Second one is also a strip. Okay. Like, okay. So same, that's it. This is a Dell technology. Technology is there. So this is about your write, guys. I hope understand. So first of all, stripped volume, and between two stripped volume, you should do mirroring. So this is a one strip. Okay, this is another strip. This is mirror. Okay. So this is about your write theory. How to stop recording? This is here only. Stop recording. If anybody is want to ask a question, please ask me. Then otherwise, I will stop recording. Okay. Then yesterday I shared a ride practical also, right? So I will show you that ride. Yeah, this is the last batch only. So luckily, even we don't have a time, I showed some practical for that one. So
this one is to combine. See.
Okay, so here it is. I started in a Windows server. I added a multiple disk. In Windows server, I added a multiple disk, and I showed how to do this kind of stuff. Okay. See, I added a multiple disk in Windows server. I showed how to do this practical. Okay, so literally you don't have a practical part in your system, in your syllabus. So, but my interest is practical. Okay, so like this, I try to show. Okay, even though write 5 up to write 5, write 0, write 1, write 5 practicals also we done. So I will give you the link again here. So for practicals. Okay, if you want to perform the practical on your own, or you want to see how to do that one, so you can get it. Okay. Really, if you got some time, really, so you can remind me, sir. We want to see how to do practical on our own. You can do it. Okay. Now stopping recording, guys.